Imagine this. You're watching this video right now when suddenly time stops. Not just slows down, completely stops. Every clock in the world freezes at the exact same second. Every bird in the sky becomes suspended mid-flight. Every drop of rain hangs motionless in the air. But here's the terrifying part. You would never know it happened. Today, we're diving deep into one of physics' most mind-bending scenarios. What would actually happen if time stopped right now? The answer involves quantum mechanics, Einstein's relativity, and some truly bizarre consequences that would make reality itself impossible. Get ready to question everything you think you know about time. What if I told you that stopping time would instantly make you blind? When we talk about time stopping, we need to understand what time actually is. Time isn't just the ticking of a clock. It's the fundamental dimension that allows change to occur in the universe. Every chemical reaction, every movement of particles, every thought in your brain requires time to happen. If time truly stopped, it wouldn't be like pressing pause on a movie. In a paused movie, you can still see the frozen frame because light is still reaching your eyes. But if time stopped, light itself would freeze. Photons would become locked in place between their source and your eyes. You'd be instantly blind. Your brain depends on electrical signals traveling between neurons. These signals move at specific speeds and require time to propagate. If time stopped, these signals would freeze mid-transmission. Your consciousness would halt instantly. You wouldn't think, "Oh, time has stopped." You simply wouldn't think at all. The very concept of experiencing stopped time is a logical impossibility. Time is so fundamental to existence that without it, the concept of you wouldn't even make sense. Your identity depends on the continuous flow of experiences and memories, all of which require time to form and connect. Consider what happens when you recognize a face or remember a song. These processes require your brain to compare current sensory input with stored memories, a process that takes time. Neural networks fire in sequence, creating patterns of activity that we experience as recognition or remembrance. The speed of these neural processes varies dramatically. Some reflexes happen in milliseconds, while complex thoughts might take seconds to form. But all of them depend on temporal sequences. Neuron A fires, triggering neuron B, which influences neuron C. Remove time from this equation, and the entire system collapses into meaningless static. Your brain becomes a frozen sculpture of organic chemistry. Beautiful, perhaps, but utterly without consciousness. Even more fundamentally, the atoms that make up your brain are in constant motion. Electrons orbit nuclei, molecules vibrate, chemical bonds form and break. This atomic dance is what allows neurons to function, proteins to fold correctly, and DNA to replicate. Stop time, and this dance freezes instantly. Every atom becomes locked in its current position and energy state. The quantum mechanical processes that enable life, the transfer of electrons in cellular respiration, the conformational changes in proteins, the hydrogen bonding in DNA, all would halt simultaneously. But here's where it gets truly strange. The very concept of stopping time assumes there's some external reference frame from which to observe the stoppage. But Einstein's relativity tells us there's no universal reference frame. Time is relative to the observer. For time to stop everywhere simultaneously, you'd need to violate one of the most fundamental principles of modern physics. You'd need absolute simultaneity across the entire universe, something that relativity explicitly forbids. Think about what now means on a cosmic scale. When you say right now, you're referring to a specific moment in your reference frame. But now on Mars is different from now on Earth due to the finite speed of light. There's no universal now that applies everywhere in the universe simultaneously. So the very premise of time, stopping everywhere at once, is physically meaningless, according to our best understanding of space-time. Yet for the sake of our thought experiment, let's imagine we could somehow freeze time in a way that preserves some form of universal simultaneity. What would this mean for the fundamental constants of physics? Time appears in nearly every physical equation. The speed of light is distance divided by time. Planck's constant relates energy to frequency, which is inverse time. The gravitational constant involves time in its units. Remove time, and these fundamental constants become undefined. This creates a universe where the laws of physics simply don't apply. It's not just that motion stops, it's that the very mathematical framework we use to describe reality becomes meaningless. Forces can't act because force is the change in momentum over time. Energy can't flow because power is energy per unit time. Even the concept of existence becomes questionable because existence implies persistence through time. The electromagnetic field equations that govern light, radio waves, and all forms of electromagnetic radiation explicitly depend on time derivatives. Without time, these equations become undefined, meaning electromagnetic phenomena couldn't exist in any meaningful sense. The quantum field equations that describe fundamental particles and forces also require time evolution. Remove time, and quantum fields become static configurations that can't interact or exchange energy. Consider the implications for causality, the fundamental principle that causes precede their effects. In a time-stopped universe, this principle becomes meaningless. Every cause would exist simultaneously with its effect, creating a logical contradiction that makes the very structure of reality incoherent. The universe wouldn't just be motionless, it would be logically impossible. Even the concept of space becomes problematic without time. Einstein showed us that space and time are inextricably linked in space-time. You can't have one without the other. Space without time isn't empty space. It's a meaningless mathematical abstraction that couldn't contain matter, energy, or information in any recognizable form. The very atoms that make up your body depend on time to maintain their structure. Electrons exist in probability clouds around atomic nuclei, and these clouds evolve continuously over time according to quantum mechanical principles. Stop time, and you freeze these probability distributions in whatever configuration they happen to be in. But quantum mechanics says this is impossible. Particles must always have some uncertainty in their properties, and this uncertainty can only be resolved through temporal evolution. This creates a paradox, where stopping time would violate the fundamental laws of quantum mechanics. The uncertainty principle requires that particles cannot have both perfectly defined positions and perfectly defined momenta simultaneously. But in a truly time-stopped universe, every particle would be frozen with both properties perfectly defined, breaking one of the most basic rules of reality. The chemical bonds that hold your body together also depend on time. These bonds form through the sharing of electrons between atoms, but this sharing is a dynamic process that requires continuous quantum mechanical evolution. Stop time, and these bonds would freeze in whatever configuration they were in, potentially causing molecules to fly apart or become locked in unstable arrangements. Your DNA contains the instructions for life, but reading these instructions requires time. DNA replication involves complex molecular machinery that must move along the DNA strand, reading the genetic code and assembling new molecules. Without time, this process would halt mid-action, leaving genetic information partially copied and completely unusable. The proteins in your body are constantly folding and unfolding, changing shape to perform their biological functions. These conformational changes happen over milliseconds to minutes, but they all require time to occur. Stop time, and every protein in your body would be locked in its current shape, unable to function or adapt to changing conditions. Even the water in your cells depends on time to maintain its liquid state. Water molecules are constantly forming and breaking hydrogen bonds with each other, creating the fluid properties that enable life. Without time, these molecular interactions would freeze, potentially turning the water in your body into a strange crystalline structure that could never support biological processes. Here's something that will blow your mind. Stopping time would require infinite energy and would instantly collapse the universe into a black hole. According to Einstein's theory of relativity, time and space are connected in something called space-time. Time can slow down near massive objects or at high speeds, but stopping time everywhere would require infinite energy or infinite mass. This would immediately collapse the universe into a singularity. But let's imagine somehow we could stop time without destroying everything. What would the frozen universe look like? Every atom would be locked in position. The electrons orbiting atomic nuclei would freeze in their quantum states. The constant motion that generates heat would stop, meaning everything would instantly reach absolute zero temperature. Water molecules in the air would stop vibrating. Sound waves, which are just moving pressure waves, would freeze mid-propagation. A person shouting would have their voice trapped in a bubble of motionless air around their mouth. The Earth would stop rotating, but it would also stop orbiting the Sun. Gravity itself depends on the curvature of space-time, and without time, even gravitational effects would freeze. The universe would become a perfect three-dimensional sculpture, completely static and eternal. But describing this frozen state is itself problematic, because description implies sequence, and sequence requires time. Consider the electromagnetic radiation filling the universe. Radio waves from distant galaxies, visible light from stars, cosmic microwave background radiation from the Big Bang, all of this would freeze in place. The universe would be filled with an intricate three-dimensional tapestry of electromagnetic fields, each wave frozen at whatever phase it happened to be in when time stopped. This creates a bizarre scenario where information exists but cannot propagate. Every radio signal, every beam of starlight, every Wi-Fi transmission would be trapped in an eternal moment between transmission and reception. The nuclear reactions powering stars would halt instantly. Fusion requires precise timing. Hydrogen nuclei must overcome the electromagnetic force at exactly the right moment to fuse into helium. Without time, this process becomes impossible. Every star in the universe would go dark simultaneously, not because they've burned out, but because the very concept of burning requires temporal processes. The energy contained within these frozen nuclear reactions would be trapped forever. In our Sun alone, 4 million tons of matter are converted to energy every second through nuclear fusion. This energy normally flows outward as light and heat, but in a time-stopped universe, it would be locked within the stellar core. The Sun would become a sphere of frozen nuclear fire, containing vast amounts of energy that could never be released. On a more intimate scale, consider what happens to chemical bonds. These bonds form when electrons are shared between atoms in precise quantum mechanical arrangements. These arrangements are dynamic. Electrons exist in probability clouds that evolve over time. Freeze time, and you freeze these probability distributions in their current state. Chemical reactions become impossible because they require atoms to rearrange their electron configurations over time. This frozen chemistry would affect everything from the rust forming on metal to the photosynthesis happening in plants. Every biological process would halt mid-reaction. Enzymes would be caught in the middle of catalyzing their target molecules. DNA polymerase would stop mid-replication, leaving genetic material partially copied. Muscle fibers would freeze in whatever state of contraction or relaxation they were in, creating a universe of statue-like beings caught in eternal poses. The thermodynamic implications are staggering. Heat is fundamentally the motion of atoms and molecules. When you feel warmth, you're sensing the average kinetic energy of particles striking your skin. In a time-stopped universe, all molecular motion would cease instantly. This doesn't just mean everything becomes cold, it means the very concept of temperature becomes undefined. You can't have temperature without motion, and you can't have motion without time. Energy conservation takes on bizarre new meaning in this scenario. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed from one form to another. But these transformations require time to occur. In our frozen universe, energy would be trapped in whatever forms it occupied at the moment of temporal cessation. Kinetic energy would be frozen in motionless objects, a logical contradiction that highlights the fundamental impossibility of our scenario. Potential energy would face similar problems. A ball balanced on the edge of a cliff has gravitational potential energy that could be converted to kinetic energy if it falls, but falling requires time. In our time-stopped universe, the ball would remain eternally balanced, its potential energy forever unrealizable. The entire concept of energy transformation would become meaningless. The electromagnetic field equations that govern all forms of radiation explicitly include time derivatives. These equations describe how electric and magnetic fields change over time and how they propagate through space. Remove time, and these equations become undefined. This means not just that electromagnetic radiation would stop moving, but that the very mathematical framework describing electromagnetic phenomena would collapse. Consider what this means for the fundamental forces. The electromagnetic force that holds atoms together operates through the exchange of virtual photons between charged particles. These exchanges happen incredibly quickly, but they still require time. Without time, electromagnetic interactions would freeze mid-exchange, potentially altering the basic structure of matter itself. Atoms might not be able to maintain their integrity without the continuous exchange of virtual particles that binds them together. The strong nuclear force faces similar problems. This force holds atomic nuclei together through the exchange of particles called gluons. These exchanges must happen over time, even if that time is measured in tiny fractions of a second. Freeze time, and you freeze these exchanges, potentially causing atomic nuclei to fly apart or become locked in unstable configurations that violate known physics. Perhaps most unsettling is what happens to causality in a time-stopped universe. Cause and effect rely on temporal sequence. Causes precede effects. Without time, this relationship becomes meaningless. Every effect exists simultaneously with its cause, creating a logical nightmare where the fundamental structure of reality breaks down. The universe becomes not just motionless, but logically incoherent. The very notion of existence becomes problematic in a timeless universe. To exist means to persist through time, to maintain identity from one moment to the next. Without moments, without sequence, without the possibility of change, can anything be said to truly exist? Or would the time-stopped universe be better described as a mathematical abstraction, a set of coordinates in space-time that describes what was but can no longer be said to be? This philosophical puzzle extends to information itself. Information requires the ability to distinguish between different states, and it requires the possibility of change to be meaningful. In a time-stopped universe, information would be frozen in place, unable to be processed, transmitted, or even properly defined. The universe would contain potential information, patterns that could be meaningful if time existed, but no actual information in any sense that matters. The concept of entropy, which measures the disorder in a system, would also become undefined. Entropy typically increases over time as systems move toward thermal equilibrium. In a time-stopped universe, entropy would be frozen at whatever value it had when time stopped. No further increase would be possible, but neither would any decrease. The second law of thermodynamics would become as meaningless as the first. Even the vacuum of space would be affected. What we call empty space is actually filled with quantum fluctuations, virtual particle pairs that constantly appear and disappear according to Heisenberg's uncertainty principle. These fluctuations happen over incredibly brief timescales, but they still require time. Stop time, and you stop these fluctuations, potentially creating a space that is truly empty rather than the dynamic, energy-filled vacuum we observe in reality. The implications extend to the largest scales of the universe as well. The cosmic expansion that has been stretching space itself for nearly 14 billion years would halt instantly. Galaxies would be frozen at their current distances from each other, unable to continue their recession or to gravitationally interact in any meaningful way. The cosmic microwave background radiation that fills the universe would be locked in place, its slight temperature variations preserved as an eternal snapshot of cosmic structure formation. What if you could somehow observe a time-stopped universe? This creates one of the most mind-bending paradoxes in physics. For you to observe a time-stopped universe, you would need to exist outside of time somehow, but existing outside time creates logical impossibilities. How would you move your eyes to look around if movement requires time? How would your brain process information if thinking requires time? Every action, every thought, every observation requires change, and change requires time. Some science fiction suggests that the person who stops time could still move around freely. But this violates basic physics. To move through space, you need to change your position over time. No time means no movement. You'd be as frozen as everything else. Even more strange, if you somehow could move in a timeless universe, you'd be moving at infinite speed from the perspective of physics. You'd cross any distance in zero time. The laws of physics would completely break down. This paradox reveals something profound about consciousness itself. Our awareness depends entirely on the flow of time, Without time, there's no experience, no thought, no existence as we understand it. Consciousness requires the ability to form memories, process sensory input, and maintain continuity of self-awareness. All of these processes are fundamentally temporal. Consider what happens when you recognize a familiar face. Your visual cortex processes the incoming light patterns, compares them with stored memory engrams, and generates the experience of recognition. This entire process unfolds over hundreds of milliseconds, involving cascades of neural activity that must occur in specific sequences. Remove time, and this process becomes impossible. The neurons involved would be frozen in whatever state they happen to be in, unable to complete the recognition process. Even more fundamentally, consciousness seems to require what philosophers call the specious present, a brief window of time during which past, present, and future perceptions are integrated into a coherent experience. This temporal integration is what allows you to follow a melody, understand a sentence, or track a moving object. Without the flow of time, consciousness fragments into disconnected moments that cannot be linked into coherent experience. The problem extends beyond just neural processing to the very physics of information. Information theory tells us that information requires distinguishable states that can change over time. A frozen universe contains no information in the technical sense because there's no way to distinguish between different states or to process changes. The universe would contain potential information, patterns that could be meaningful if time existed, but no actual information transfer or processing. This creates a philosophical puzzle about the nature of existence itself. If consciousness requires time and time has stopped, do conscious beings still exist in any meaningful sense? Are they simply complex arrangements of matter with no inner experience, like sophisticated but inactive computers? Or does the stoppage of time negate existence entirely? The question touches on fundamental issues about the relationship between mind and matter, between subjective experience and physical reality. The paradox deepens when we consider that observation itself is a physical process. Seeing requires photons to travel from objects to your eyes, where they trigger electrochemical cascades that create visual experience. Hearing requires sound waves to propagate through air and vibrate structures in your inner ear. Touch requires electromagnetic forces between atoms to generate pressure sensations. All of these processes require time to unfold. In a time-stopped universe, an observer would be cut off from all sensory input. They couldn't see the frozen world because light couldn't reach their eyes. They couldn't hear the silence because sound waves couldn't propagate. They couldn't feel anything because the electromagnetic forces that create tactile sensations couldn't propagate through matter. The observer would exist in a sensory void, unable to perceive anything about the frozen reality around them. But the paradox goes even deeper. The very concept of being able to observe implies the existence of an observer with functional sensory systems and a working brain. But brains require time to function. Neurons fire in sequences, neurotransmitters cross synapses, electrical signals propagate along nerve fibers, all temporal processes. A brain in a time-stopped universe would be as frozen as everything else, incapable of generating consciousness or processing sensory information. This leads us to the ultimate observer paradox. To observe a time-stopped universe, you would need to be outside the stopped time, but if you're outside stopped time, you're not in the same universe. You would need to exist in a separate temporal dimension, with your own flow of time that continues while the observed universe remains frozen. This requires the existence of multiple time dimensions, something for which there's no evidence in physics. Even if we imagine multiple time dimensions, the problems multiply. How would information about the frozen universe reach an observer in a different temporal dimension? Information transfer requires some form of interaction, and interactions require shared physical processes. If the observer exists in a different time dimension, there's no mechanism by which they could receive information about the frozen universe. The mathematics of observation also breaks down in a timeless universe. The act of measurement in quantum mechanics requires the interaction between a quantum system and a measuring device. This interaction unfolds over time as the quantum system becomes entangled with the measurement apparatus and its wave function collapses into a definite state. Without time, quantum measurements become impossible, leaving all quantum systems in permanent superposition. Consider what this means for the basic act of seeing. Vision works because photons emitted or reflected by objects travel through space and strike the retina, where they trigger biochemical changes that generate electrical signals sent to the brain. Each step in this process requires time. Photons must travel from object to eye. Rhodopsin molecules in the retina must change shape when struck by photons. Electrical signals must propagate along the optic nerve to the visual cortex. Neural networks must process these signals to create visual perception. In a time-stopped universe, this entire chain of events would be broken. Photons would be frozen between objects and eyes. Rhodopsin molecules would be locked in their current configurations. Electrical signals would be trapped mid-transmission in the optic nerve. The visual processing networks in the brain would be frozen in whatever pattern of activity they had when time stopped. The same problems apply to all other senses. Hearing depends on sound waves propagating through air and vibrating the eardrum, which in turn vibrates tiny bones that stimulate hair cells in the inner ear. These hair cells generate electrical signals that travel to the auditory cortex. Every step requires time. Smell works through molecules binding to receptors in the nose, triggering biochemical cascades that create electrical signals. Taste involves similar molecular interactions on the tongue. Touch requires pressure waves or heat to propagate through matter and stimulate nerve endings. All of these sensory processes would be frozen in a time-stopped universe. An observer would be completely cut off from any information about their surroundings. They would exist in a sensory void, unable to see, hear, smell, taste, or feel anything about the frozen world around them. But perhaps the most profound aspect of the observer paradox is what it reveals about the nature of consciousness itself. Consciousness isn't just about processing sensory information. It's about the continuous flow of subjective experience. We experience ourselves as persisting through time, maintaining identity from moment to moment, despite constant changes in our thoughts, sensations, and memories. This continuity of consciousness requires time. Memory formation requires time for neural patterns to stabilize and strengthen. The sense of self requires time to maintain coherence across changing experiences. Even basic awareness requires time for information to flow through neural networks and create the integrated experience we call consciousness. Without time, consciousness would fragment into disconnected moments with no relationship between them. There would be no flow of experience, no sense of continuity, no possibility of thought or awareness as we understand them. The observer would cease to exist as a conscious entity, becoming instead a static pattern of neural activity frozen in time. This brings us to the ultimate conclusion of the observer paradox. In a truly time-stopped universe, there can be no observers. The very possibility of observation requires the flow of time. A time-stopped universe would be not just unobservable, but fundamentally unobservable in principle. It would exist beyond the reach of any possible consciousness or awareness. In a time-stopped universe, light would become the ultimate prison. Light waves would be locked in place like invisible highways, stretching between every source and destination. The photons from your phone screen would freeze just inches from your eyes. Energy itself would become meaningless. Energy is the capacity to do work over time. Without time, no work can be done. All the energy in the universe would be frozen in place. Kinetic energy, trapped in motionless particles, potential energy locked in position. Heat is actually the random motion of atoms. In a frozen universe, this motion would stop, instantly bringing everything to absolute zero temperature. But even the concept of temperature becomes meaningless without time, since temperature is a measure of average kinetic energy over time. Electromagnetic fields would freeze. The Earth's magnetic field, radio waves, X-rays, gamma rays, all would become static patterns locked in space. The universe would be filled with frozen electromagnetic sculptures that no one could see or detect. Even stranger, without time, the concept of frozen doesn't make sense either. Things aren't frozen in time. They simply exist in an eternal, unchanging state where the concept of change has no meaning. The electromagnetic spectrum would create an intricate three-dimensional artwork throughout space. Radio telescopes would have their signals trapped just short of their receivers. The cosmic microwave background radiation would form a complex pattern of frozen waves, carrying information about the early universe that could never be decoded. Consider what happens to the various forms of electromagnetic radiation. Visible light would create rainbow highways stretching from every light source to every destination. Infrared radiation from warm objects would be trapped in glowing aureoles around every heated surface. Ultraviolet radiation from the sun would form a vast, complex beam structure extending throughout the solar system. X-rays from distant black holes would be frozen mid-journey across galactic distances. The radio spectrum would be particularly fascinating. Every radio transmission, from AM radio to satellite communications to deep space signals from other galaxies, would be trapped as standing wave patterns in space. The universe would be crisscrossed with invisible information highways, carrying everything from music to GPS signals to scientific data, all frozen in transit between transmitter and receiver. Imagine the complexity of this electromagnetic sculpture. Cell phone signals would be trapped as three-dimensional networks, connecting every phone to every cell tower. Wi-Fi signals would create intricate patterns around routers and devices. Bluetooth connections would form short-range geometric patterns. Every form of wireless communication would be preserved as a static artwork of electromagnetic radiation, carrying digital information that could never reach its destination. Gamma rays from stellar explosions and cosmic ray interactions would create the most energetic component of this frozen electromagnetic tapestry. These high-energy photons would be locked in place like invisible spears piercing through space, carrying enormous amounts of energy that could never be absorbed or detected. The entire electromagnetic heritage of the universe, every signal ever transmitted, every ray of light ever emitted, would be preserved as a vast, static monument to the communication and energy transfer that once flowed through space. Photosynthesis would halt with chlorophyll molecules frozen in mid-reaction, their electron transport chains locked at whatever stage they were in when time stopped. The delicate quantum mechanical processes that convert sunlight into chemical energy would be trapped in an eternal moment, neither completing nor resetting. Plants would become living statues with their molecular machinery preserved in perfect detail but completely non-functional. Solar panels would be equally helpless, their photovoltaic cells containing frozen electrons that were knocked loose by incoming photons but could never complete their journey to create electrical current. The photoelectric effect would become a museum display of quantum mechanics rather than a working phenomenon. Every semiconductor device would be trapped mid-operation, with electrons frozen in their energy bands, unable to conduct electricity or process information. Energy conservation would take on bizarre new meaning in a time-stopped universe. Energy can neither be created nor destroyed, but it can change forms. Without time, no energy transformations could occur. Kinetic energy would be trapped in motionless objects, a contradiction that reveals the fundamental impossibility of our scenario. Potential energy would be locked at its current values, unable to be converted to kinetic energy or any other form. The wave-particle duality of light would create strange paradoxes in a frozen universe. Light behaves both as waves and as particles, depending on how it's observed. But observation requires time. You need time for photons to interact with detectors, time for wave functions to collapse, time for measurement results to be recorded. Without time, light would be trapped in a quantum superposition between wave and particle states, unable to resolve into either form. Maxwell's equations, which describe all electromagnetic phenomena, explicitly depend on time derivatives. These equations show how changing electric fields create magnetic fields and vice versa, allowing electromagnetic waves to propagate through space. Remove time, and these equations become undefined. Not only would electromagnetic radiation stop moving, but the very mathematical framework describing electromagnetism would collapse. The speed of light, one of the most fundamental constants in physics, becomes meaningless in a time-stopped universe. Speed is distance divided by time, so without time the concept of speed cannot exist. Light wouldn't be moving slowly or quickly, it simply wouldn't be moving at all. The photons would exist as static points in space, like a three-dimensional constellation of trapped energy. The Doppler effect, which causes the frequency of waves to change when sources and observers move relative to each other, would become meaningless in a time-stopped universe. Police radar, astronomical redshift measurements, and even the pitch changes you hear when an ambulance passes by all depend on the Doppler effect. With time stopped, there would be no relative motion and no frequency changes, freezing all wave phenomena at their current states. Interference patterns, where waves combine to create areas of reinforcement and cancellation, would be locked in place. The beautiful interference patterns created by light passing through double slits, the standing wave patterns in microwave ovens, the complex interference effects in optical instruments, all would be preserved as static sculptures of wave interaction. Even the quantum vacuum would be affected by the stoppage of electromagnetic phenomena. Empty space is filled with virtual photon pairs that constantly appear and disappear according to quantum field theory. These virtual particles are responsible for fundamental forces and quantum effects like the Casimir force. In a time-stopped universe, these quantum fluctuations would freeze, potentially altering the basic properties of empty space itself. The electromagnetic force that holds atoms and molecules together operates through the continuous exchange of virtual photons between charged particles. This exchange happens on timescales of 10 to the negative 21st power seconds, incredibly brief but still requiring time. Stop time, and you stop these exchanges, potentially causing atoms to lose their structural integrity as the electromagnetic bonds that hold them together are interrupted mid-formation. Light pollution from cities would create fascinating frozen patterns in a time-stopped universe. The orange glow of sodium streetlights, the blue-white glare of LED bulbs, the multicolored neon signs, all would be trapped as static light sculptures, frozen between their sources and destinations. The night sky would become a complex three-dimensional artwork, combining natural starlight with artificial illumination. The aurora borealis and aurora australis would be frozen mid-dance. These beautiful light displays occur when charged particles from the solar wind interact with Earth's magnetic field and atmosphere. In a time-stopped universe, these particles would be locked in position, creating permanent aurora patterns that could never shimmer or move. The solar wind itself would crystallize into static streams of charged particles flowing from the sun. Lasers would create perfect straight-line sculptures of coherent light. The intense focused beams used in everything from barcode scanners to industrial cutting would be frozen in place, creating invisible but perfectly straight lines of trapped photons. The coherent properties that make laser light useful for precision measurements and communications would be preserved but rendered completely non-functional. Fiber optic cables would become galleries of trapped light signals. The infrared pulses that carry internet data through these cables would be frozen mid-transmission, preserving the exact pattern of digital information that was flowing at the moment time stopped. Every email, every video stream, every web page request would be crystallized as patterns of light trapped within glass fibers. Perhaps most poetically, the light from distant stars would be frozen on its journey to Earth. Light that has traveled for millions of years across the cosmos would be trapped just short of reaching our telescopes. We would be surrounded by invisible shells of ancient starlight, each one carrying information about stellar events that occurred in the distant past, but which could never complete their journey to tell us their stories. Quantum mechanics in a time-stopped universe would create impossible contradictions. At the quantum level, particles don't have definite positions. They exist in probability clouds called wave functions. These wave functions constantly evolve and change over time. If time stopped, quantum particles would be trapped in whatever state they happen to be in at that exact moment. But quantum mechanics says this is impossible. The uncertainty principle requires that particles must have some uncertainty in their position and momentum simultaneously. Stopping time would violate this fundamental principle. You'd have particles with perfectly defined positions and perfectly defined momenta, which quantum mechanics says is impossible. The universe would break its own rules. Radioactive decay depends on quantum uncertainty and happens over time. In a frozen universe, radioactive materials would stop decaying. Nuclear reactions in the sun would halt. Even the quantum fluctuations that create virtual particles in empty space would freeze. This creates a universe that's not just motionless, but fundamentally impossible according to our understanding of physics. Time isn't just a convenience, It's absolutely essential for reality to exist as we know it. The Schrödinger equation, which describes how quantum systems evolve, is explicitly time-dependent. Remove time, and quantum mechanics loses all predictive power. Wave functions become static probability, distributions that can never collapse into definite outcomes. Consider what happens to quantum tunneling, the effect that allows particles to pass through energy barriers that should be impossible to cross classically. This effect depends on the time evolution of wave functions. In a frozen universe, particles approaching energy barriers would be trapped eternally at the barrier edge, neither tunneling through nor bouncing back. The quantum world would become a gallery of frozen probability rather than the dynamic, ever-changing system we observe. Imagine an electron approaching the barrier of an atomic nucleus. In normal circumstances, there's a small probability that the electron could tunnel through the barrier and escape the atom. This tunneling process requires time for the electron's wave function to evolve and penetrate the barrier. In a time-stopped universe, the electron would be frozen at the barrier edge, its wave function locked in a state of eternal approach but never able to complete the tunneling process. Quantum entanglement would face similar problems. Entangled particles maintain their mysterious connection through correlations that unfold over time. When one particle's properties are measured, its entangled partner instantly knows about the measurement and adjusts its own properties accordingly. But this correlation requires the concept of sequence. First one measurement, then the correlated response. Without time, entanglement becomes a meaningless concept. The spookiness of quantum entanglement, which Einstein famously called spooky action at a distance, depends entirely on temporal sequence. When you measure the spin of one entangled particle, its partner immediately adopts the opposite spin. But immediately and then are temporal concepts that require time to have meaning. In a frozen universe, entangled particles would be trapped in their correlated states, unable to demonstrate the mysterious connection that makes quantum mechanics so strange. The quantum vacuum itself depends on time. Empty space is actually filled with virtual particle pairs that constantly appear and disappear on timescales determined by Heisenberg's uncertainty principle. These quantum fluctuations are responsible for phenomena like the Casimir effect and Hawking radiation. In a time-stopped universe, these fluctuations would freeze, creating a space filled with virtual particles trapped in permanent existence, neither fully real nor properly virtual. This freezing of the quantum vacuum would have profound consequences. The virtual photons that mediate electromagnetic forces between charged particles would be trapped mid-exchange. The virtual gluons that hold quarks together inside protons and neutrons would freeze in place. Even the virtual particles that give mass to the Higgs field would be locked in static configurations, potentially altering the fundamental properties of matter itself. Even the concept of quantum superposition becomes problematic. Superposition allows particles to exist in multiple states simultaneously until measured, but the measurement process itself takes time, involving the interaction between the quantum system and the measuring device. Without time, measurements could never complete, leaving quantum systems trapped forever in superposed states that could never resolve into definite outcomes. Consider Schrödinger's famous thought experiment with the cat that is simultaneously alive and dead until observed. In a time-stopped universe, the cat would be trapped forever in this superposed state. The quantum measurement that would normally collapse the wave function and determine whether the cat lives or dies could never occur because the measurement process requires time to unfold. The fundamental forces of nature would behave strangely in a time-stopped universe. The electromagnetic force, which holds atoms together and creates all chemical bonds, depends on the exchange of virtual photons between charged particles. These exchanges happen over time, even if it's incredibly brief. Without time, electromagnetic interactions would freeze mid-exchange, potentially altering the structure of matter itself. The strong nuclear force faces even more severe problems. This force holds atomic nuclei together through the exchange of gluons, particles that carry the strong force between quarks. These exchanges must occur over time to maintain nuclear stability. In a time-stopped universe, the strong force would be unable to function, potentially causing atomic nuclei to fly apart or become locked in impossible configurations. Quantum field theory, which describes all fundamental particles and forces, is built on the concept of fields that fluctuate over time. These quantum fields pervade all of space, and particles are excitations of these fields. Without time, quantum fields would become static, unchanging entities that could not create or destroy particles or mediate forces between them. The wave-particle duality that defines quantum mechanics would create paradoxes in a timeless universe. Particles exhibit wave-like or particle-like properties depending on how they're observed, but observation is a time-dependent process. In a frozen universe, particles would be trapped in quantum superposition between wave and particle states, unable to manifest either property because the observation process could never complete. Quantum decoherence, the process by which quantum systems lose their quantum properties and become classical, requires time to occur. This process happens when quantum systems interact with their environment, causing their wave functions to evolve and lose coherence. Without time, decoherence would be impossible, leaving the entire universe in a quantum superposition that could never resolve into the classical reality we observe. The quantum Zeno effect, where frequent measurements can freeze the evolution of a quantum system, would become absolute in a time-stopped universe. But unlike the normal Zeno effect, which requires repeated measurements over time, a truly time-stopped universe would freeze quantum evolution without any measurements at all. Every quantum system would be locked in its current state forever. Quantum spin, an intrinsic property of particles, would create strange effects in a frozen universe. Spin is not actual rotation, but a quantum property that can be measured along different axes. The relationships between spin measurements along different axes depend on the time evolution of quantum states. Without time, these relationships would break down, potentially violating conservation laws and creating logical contradictions. The uncertainty principle extends beyond position and momentum to include energy and time. There's a fundamental uncertainty relationship between the energy of a quantum state and the time over which it can be measured. In a time-stopped universe, this energy-time uncertainty would become infinite, making it impossible to define the energy of any quantum state. Quantum computers rely on quantum superposition and entanglement to perform calculations. These devices manipulate quantum states over time to solve problems that would be impossible for classical computers. In a time-stopped universe, quantum computers would be frozen mid-calculation, their qubits locked in superposed states that could never be read or manipulated. Even the quantum mechanical description of ordinary matter would break down. The chemical bonds that hold molecules together are quantum mechanical phenomena that require time to form and maintain. Electrons in these bonds exist in molecular orbitals that are constantly evolving quantum states. Stop time, and you freeze these orbitals, potentially causing all chemical bonds to break or become permanently rigid. The photoelectric effect, which Einstein used to prove the particle nature of light, requires time for photons to knock electrons out of atoms. In a time-stopped universe, this process would halt midway, with photons frozen in the act of striking electrons but unable to complete the energy transfer. This would make it impossible to generate electrical current from light, rendering solar panels and photodetectors useless. Quantum chromodynamics, the theory describing the strong force, involves complex time-dependent interactions between quarks and gluons within atomic nuclei. These interactions are what give protons and neutrons their mass and hold them together in atomic nuclei. Without time, these interactions would freeze, potentially altering the fundamental properties of matter and causing atomic nuclei to become unstable or cease to exist entirely. Einstein showed us that gravity isn't a force, it's the curvature of space-time itself. Massive objects bend space-time, and this bending is what we experience as gravity. But what happens to gravity when time stops? If time stops everywhere simultaneously, space-time itself would cease to exist in any meaningful way. You'd have space without time, which Einstein showed us is impossible. Gravity depends on the flow of time to function. Objects fall toward massive bodies because they follow the shortest path through curved space-time. Without time, there's no path to follow. Gravity would simply cease to exist. The Earth would stop pulling on you. The Sun would stop pulling on the Earth. But here's the really weird part. If somehow gravity could still function without time, it would have to act instantaneously. Objects would have to know immediately about changes in gravitational fields. This would require information to travel faster than light, violating relativity. The mathematical equations that describe gravity include time as a fundamental variable. Remove time, and the equations become meaningless. You can't have curved spacetime without the time part of spacetime. Einstein's field equations relate the curvature of spacetime to the energy and matter it contains. These equations are differential equations that describe how curvature changes over time in response to changes in energy distribution. Without time, the concept of change becomes undefined, making the equations unsolvable. Consider what happens to gravitational waves, ripples in spacetime itself that travel at the speed of light. These waves are produced by accelerating massive objects like colliding black holes or neutron stars. In a time-stopped universe, any gravitational waves in transit would freeze mid-propagation, creating static distortions in the fabric of space. These frozen waves would preserve information about cosmic catastrophes that occurred before time stopped, creating a permanent record of gravitational violence encoded in the structure of space itself. Imagine the LIGO detectors that have revolutionized our understanding of the cosmos by detecting gravitational waves. In a time-stopped universe, these incredibly sensitive instruments would be frozen mid-detection, their laser interferometry systems locked with gravitational waves partially passing through their arms. The waves themselves would be trapped as permanent wrinkles in spacetime, stretching and compressing space but unable to propagate any further. Tidal effects would also freeze in place. The Moon's gravity creates bulges in Earth's oceans that we experience as tides. In a time-stopped universe, these bulges would be locked in position, creating permanent high and low tide regions that could never change. The Earth's shape itself, slightly flattened by its rotation and stretched by the Moon's gravity, would be preserved exactly as it was at the moment time stopped. The concept of gravitational potential energy would become meaningless. A rock balanced on the edge of a cliff has gravitational potential energy that could be converted to kinetic energy if it falls. But falling requires time. In our time-stopped universe, the rock would remain eternally balanced, its potential, energy forever unrealizable. The entire concept of gravitational work, the energy required to move objects against gravitational fields, would become undefined. Black holes would face particular problems in a time-stopped universe. These objects are defined by their event horizons, the boundary beyond which nothing can escape because it would require traveling faster than light. But the very concept of an event horizon depends on the flow of time. Light takes time to travel, and the horizon exists precisely because light cannot complete its journey to escape. Without time, the concept of escape becomes meaningless, and black holes would become strange objects with undefined boundaries. The event horizon itself is defined mathematically as the surface where the escape velocity equals the speed of light. But velocity is distance divided by time, so without time, the concept of escape velocity becomes undefined. Black holes would exist as regions of extreme spacetime curvature, but the boundary that makes them black would lose all meaning. Even more bizarre, black holes are thought to emit Hawking radiation through quantum effects at their event horizons. This radiation depends on virtual particle pairs where one particle escapes while the other falls into the black hole. This process requires time to unfold. The particles must separate, travel, and either escape or be absorbed. In a time-stopped universe, this process would halt, potentially preserving black holes forever in their current state. The information paradox of black holes would become even more paradoxical. Information that falls into a black hole is thought to be preserved and eventually returned through Hawking radiation. But this process takes enormous amounts of time, longer than the current age of the universe for stellar mass black holes. In a time-stopped universe, information would be trapped forever, unable to escape through the Hawking process that requires temporal evolution. The strong equivalence principle, which states that gravitational acceleration is indistinguishable from acceleration due to other forces, would break down completely. Acceleration is change in velocity over time. Without time, there can be no acceleration, gravitational or otherwise. The fundamental principle that underlies general relativity would become meaningless. Orbital mechanics would create fascinating frozen sculptures in space. Planets would be locked in their elliptical paths around the Sun, unable to continue their cosmic dance. The International Space Station would be frozen in its orbit around Earth, neither falling nor flying away. Comets approaching the Sun would be trapped mid-approach, their icy tails sublimating in the solar wind but unable to move any further along their orbital paths. The precession of Mercury's orbit, one of the key confirmations of general relativity, would halt instantly. Mercury's orbit slowly rotates around the Sun due to relativistic effects that Einstein's theory predicted with perfect accuracy. In a time-stopped universe, this precession would freeze, preserving Mercury's orbital orientation exactly as it was when time stopped. Gravitational lensing, where massive objects bend light paths like cosmic magnifying glasses, would create permanent distortion patterns. Light from distant galaxies would be frozen in the act of bending around intervening massive objects. Astronomers use gravitational lensing to study dark matter and distant cosmic structures, but in a time-stopped universe, these light rays would be trapped in their curved paths, unable to complete their journey to our telescopes. The expansion of the universe itself would halt instantly. Space has been stretching for nearly 14 billion years, carrying galaxies away from each other in the cosmic expansion discovered by Hubble. This expansion is described by general relativity and requires time to occur. In a time-stopped universe, cosmic expansion would freeze, leaving galaxies at their current distances forever. Dark energy, the mysterious force driving the accelerating expansion of the universe, would become completely inert. Whether dark energy is a cosmological constant or a dynamic field, its effects require time to manifest. The cosmic acceleration that dark energy produces would halt, freezing the universe's expansion rate at whatever value it had when time stopped. The formation of gravitational structures would cease entirely. Galaxy formation, stellar collapse, the accretion of matter onto black holes, all of these processes require gravitational attraction to work over time. Matter would be frozen in whatever configuration it had, unable to clump together under its own gravity to form new cosmic structures. Perhaps most fundamentally, the geometry of space-time itself would become static. Space-time is dynamic. It curves and flexes in response to the matter and energy it contains. This dynamical behavior is what allows gravitational waves to propagate and what makes possible the rich variety of cosmic phenomena we observe. In a time-stopped universe, space-time would become a rigid geometric structure, unable to respond to changes in matter distribution because change itself would be impossible. The GPS satellites that enable modern navigation depend on precise corrections for both special and general relativistic effects. Time dilation due to their orbital velocity and the weaker gravitational field at their altitude affects their onboard clocks. In a time-stopped universe, these satellites would be frozen with their atomic clocks locked at whatever time they displayed when temporal flow ceased, making satellite navigation impossible even if the signals could somehow propagate. Einstein's famous equation E equals mc squared would lose all meaning in a time-stopped universe. Energy and mass are equivalent and can be converted from one form to another, but these conversions require time to occur. Nuclear reactions that convert mass to energy, particle accelerators that give kinetic energy to matter, even chemical reactions that involve tiny mass-energy conversions, all would be frozen in their current states. If time stopped right now, what would happen to your body? Every biological process depends on chemical reactions, and chemical reactions require time to occur. Your heart would freeze mid-beat, with blood trapped in your arteries and veins. Your lungs would stop mid-breath, with air molecules locked in position within your airways. The oxygen in your bloodstream would be trapped exactly where it is, unable to reach your cells. But this wouldn't matter, because your cells would stop consuming oxygen anyway. Your brain contains roughly 86 billion neurons, each one firing electrical signals constantly. These signals travel at about 120 meters per second. If time stopped, these signals would freeze mid-transmission, trapping thoughts and memories in an incomplete state. Your DNA would stop replicating, proteins would stop folding, enzymes would stop catalyzing reactions. Even your body temperature would instantly drop to absolute zero as molecular motion ceased. But here's something even stranger. In a truly time-stopped universe, the concept of your body becomes questionable. Identity and consciousness require continuity over time. Without time, you're not a person, you're just a collection of frozen atoms arranged in a particular pattern. The chemical processes that maintain cellular structure would halt instantly. ATP synthesis would stop, leaving cells without their primary energy source. The sodium-potassium pumps that maintain nerve function would freeze, along with all other active transport mechanisms. Consider what happens to your digestive system. Food in your stomach would stop breaking down. Digestive enzymes would be trapped mid-reaction with their substrate molecules. The peristaltic waves that move food through your intestines would freeze, creating a permanent map of your digestive state at that exact moment. Your liver would stop processing toxins, your kidneys would stop filtering blood, your lungs would stop exchanging gases. The complexity of what would be frozen is staggering. Every enzyme in your body is caught in the middle of its catalytic cycle. Pepsin in your stomach might be trapped with a protein molecule halfway through being cleaved. Amylase in your saliva would be locked in the process of breaking down starches. Your pancreatic enzymes would be frozen with their substrate molecules bound but unable to complete their chemical transformations. Your immune system would become a frozen army. White blood cells pursuing infections would be trapped mid-chase. Antibodies would be locked onto their target antigens. Any ongoing immune responses would be preserved like three-dimensional photographs of microscopic warfare. Viruses attempting to replicate would be caught in mid-infection, their genetic material partially inserted into host cells, but unable to complete the takeover. The viral replication happening in your body at any given moment would create fascinating frozen tableau. DNA polymerases copying viral genomes would be caught mid-synthesis, with new nucleotides partially added to growing DNA chains. Viral proteins would be trapped in various stages of assembly. The complex molecular machinery that viruses hijack from host cells would be frozen in the act of creating new viral particles. The electrical system of your heart would present a fascinating study in frozen bioelectricity. The cardiac action potential that causes your heart to beat depends on the coordinated flow of sodium, potassium, and calcium ions through cellular membranes. These ions move through protein channels that open and close in precisely timed sequences. Freeze time, and you freeze this intricate electrochemical dance at whatever stage it happened to be in. Your heart might be caught mid-contraction, with some cardiac muscle cells in systole and others in diastole. The electrical impulse from your sinoatrial node could be frozen halfway through its journey across your heart muscle. The atrioventricular node might be trapped in the middle of delaying the electrical signal between your atria and ventricles. Your ECG would show a single moment of cardiac electrical activity stretched into eternity. Your nervous system would become an elaborate sculpture of frozen information. Action potentials racing along nerve fibers would stop mid-transmission. Synapses would be caught in various stages of neurotransmitter release and uptake. The complex network activity that generates consciousness would be preserved as a static pattern of electrical and chemical states, beautiful but utterly without function. The synaptic transmission happening throughout your nervous system would be frozen at every stage. Neurotransmitter vesicles approaching synaptic clefts would be locked in position. Some synapses would be caught with neurotransmitters already released but not yet bound to receptors. Others would be trapped with receptor proteins changing shape in response to neurotransmitter binding. The reuptake pumps that recycle neurotransmitters would be frozen mid-transport. Even your sense organs would be frozen mid-sensation. Photons striking your retina would stop before completing the photochemical cascade that creates vision. The rhodopsin molecules in your rod cells might be caught in the process of changing shape when struck by light. Sound waves in your inner ear would freeze before they could bend the hair cells that detect them. The stereocilia in your cochlea would be trapped in whatever position they occupied when the sound waves stopped. Your olfactory system would preserve a moment of smell. Odorant molecules would be frozen in the process of binding to receptors in your nasal epithelium. The G-protein-coupled receptors that detect smells would be caught in various stages of conformational change. The complex cascade of molecular events that transforms a chemical stimulus into a neural signal would be preserved as a static snapshot of sensory transduction. Your endocrine system would freeze with hormones trapped mid-circulation. Insulin molecules would be caught in transit between pancreatic cells and their target tissues. Growth hormones would be locked in the bloodstream, unable to reach their destinations. The complex feedback loops that regulate everything from blood sugar to stress responses would be broken, leaving the body's regulatory systems in whatever state they happen to be in at the moment of temporal cessation. The hormonal signaling cascades would create intricate frozen sculptures throughout your body. Testosterone molecules might be caught in the process of binding to androgen receptors. Thyroid hormones could be trapped entering target cells. The second messenger systems that amplify hormonal signals, cyclic AMP, calcium ions, protein kinases, would all be frozen in various stages of their signaling cascades. Your circulatory system would become a complex hydraulic sculpture. Blood would be trapped in your arteries, veins, and capillaries at whatever pressure it had when time stopped. Red blood cells would be frozen mid-flow, some squeezing through tiny capillaries, others traveling through larger vessels. The oxygen bound to hemoglobin would be locked in place, unable to be released to tissues that could no longer use it anyway. The blood flow patterns would create beautiful frozen geometries. In your lungs, blood would be trapped in the process of picking up oxygen and releasing carbon dioxide. In your kidneys, blood would be frozen mid-filtration, with some plasma being processed into urine, while other portions are returned to circulation. Your liver would contain blood in various stages of processing, removing toxins and adding nutrients. Even the microscopic processes would be arrested. Mitochondria throughout your body would be caught in the middle of cellular respiration. The electron transport chain would be frozen with electrons trapped between protein complexes. ATP synthase motors would be locked in whatever rotational position they occupied. The citric acid cycle would halt with metabolic intermediates frozen in their enzyme binding sites. Your skeletal muscles would preserve their exact state of contraction or relaxation. Myosin heads would be caught in various stages of their power stroke, some bound to actin filaments, others in the process of releasing. The calcium ions that trigger muscle contraction would be frozen in position, some bound to troponin, others still traveling through the sarcoplasmic reticulum. Your skin would become a frozen barrier preserving the exact moment of cellular renewal. Keratinocytes in various stages of maturation would be locked in the epidermis. Melanocytes would be caught in the process of producing melanin. Sweat glands would be frozen mid-secretion, their ducts containing droplets of perspiration that could never reach the surface. Every process in the universe acts like a clock, and stopping time would freeze them all simultaneously. Atomic clocks measure time by counting the vibrations of cesium atoms. These atoms vibrate 9 billion, 192 million, 631,770 times per second, with incredible precision. If time stopped, these vibrations would halt instantly. But atomic clocks aren't just measuring time, they're participating in the fundamental rhythm of reality itself. The vibrations of atoms are how the universe keeps time at its most basic level. Stars are massive fusion clocks, converting hydrogen to helium at precise rates. The nuclear reactions in stellar cores follow quantum mechanical probabilities that depend on time. Without time, stars would stop burning instantly. Pulsars are the universe's most accurate clocks, spinning neutron stars that emit radio beams with timing more precise than atomic clocks. Their rotation depends on conservation of angular momentum over time. Stop time, and even these cosmic lighthouses would go dark. The expansion of the universe itself is a kind of cosmic clock, with space growing larger over time. In a time-stopped universe, expansion would halt, freezing the cosmos at its current size forever. This would affect the cosmic microwave background radiation, which carries information about the universe's early history. The slight temperature variations in this background radiation would be frozen in place, preserving a snapshot of cosmic structure formation at the exact moment time stopped. Consider the various astronomical phenomena that act as natural clocks. Variable stars pulsate with regular periods, changing brightness as they expand and contract. These stellar heartbeats would freeze mid-pulse, preserving stars in whatever phase of their pulsation cycle they happen to be in. Cepheid variables, which astronomers use as standard candles to measure cosmic distances, would be caught at random points in their brightness cycles, some at maximum luminosity, others at minimum, creating a frozen constellation of interrupted stellar rhythms. Binary star systems orbit each other with clockwork precision, gradually spiraling inward due to gravitational wave emission. These cosmic dances would stop instantly, freezing orbital mechanics at their current configuration. Some binary pairs would be trapped at the closest approach of their elliptical orbits, others at their farthest separation. The complex gravitational choreography that has been unfolding for millions of years would become a static sculpture of celestial mechanics. Planetary rotations and orbital motions would create a frozen snapshot of our solar system. Earth would stop spinning, creating permanent day and night sides. The terminator line, the boundary between day and night, would become a permanent feature, with one hemisphere locked in eternal sunshine and the other in perpetual darkness. The moon would halt in its orbit, freezing tidal patterns and ending the rhythmic rise and fall of Earth's oceans that has continued for billions of years. Mars would stop rotating, ending its dust storms and weather patterns. The planet's thin atmosphere would be caught mid-circulation, with some regions experiencing Martian winds while others remain perfectly still. The polar ice caps would be frozen in their current seasonal state, unable to sublimate or grow with the changing Martian seasons that would never come. The giant planets would cease their complex atmospheric dynamics. Jupiter's Great Red Spot, a storm larger than Earth that has been raging for centuries, would be frozen in place. The hexagonal storm pattern at Saturn's North Pole would become a permanent geometric feature. The dynamic cloud bands that circle these gas giants would be locked in their current configurations, creating static portraits of atmospheric chaos. Comets approaching the Sun would freeze mid-approach, their tails of sublimated ice and dust locked in place like cosmic streamers. Halley's Comet, if it happened to be returning during the temporal freeze, would be trapped with its characteristic tail pointing away from the Sun, unable to complete its 76-year orbital cycle. The solar wind that shapes these tails would crystallize into static streams of charged particles flowing from the Sun. Even more exotic cosmic clocks would stop. Gamma-ray bursts from distant galaxies would freeze mid-explosion, their jets of high-energy radiation trapped in transit across cosmic distances. These bursts, thought to be caused by the collision of neutron stars or the formation of black holes, would be preserved as permanent beacons of cosmic violence, their energy locked in streams of gamma rays that could never complete their journey across the universe. The merger of neutron stars would halt mid-collision, preserving the moment of impact when gravitational waves and electromagnetic radiation are simultaneously released. The kilonova explosions that create heavy elements like gold and platinum would be frozen at the instant of element formation, with newly created atoms trapped in the stellar furnace that birthed them. Radioactive decay provides another universal timekeeper that would freeze. The half-lives of radioactive elements are fundamental constants that never change under normal circumstances. Carbon-14 dating relies on the steady decay of this isotope with a half-life of 5,730 years. In a time-stopped universe, all radioactive decay would halt, preserving the exact ratios of isotopes that existed at that moment, and making any form of radiometric dating impossible for hypothetical future observers. The implications for geology would be profound. Uranium-238 decaying to lead-206, potassium-40 transforming to argon-40, rubidium-87 becoming strontium-87. All of these radioactive decay chains that geologists use to date rocks and determine the age of Earth would be frozen mid-transformation. Some atomic nuclei would be caught in the process of emitting alpha particles, others in the middle of beta decay, creating a frozen museum of nuclear transformation. The geological processes that shape our planet would also freeze instantly. Tectonic plates would stop moving, halting the slow dance of continental drift. The mid-Atlantic ridge would cease spreading, ending the process that has been separating Europe from North America for millions of years. Subduction zones would freeze with oceanic plates trapped mid-descent into Earth's mantle. Volcanic eruptions would be caught mid-explosion, with lava frozen in spectacular arcs and ash clouds suspended in permanent sculptural formations. Yellowstone's geysers would be trapped mid-eruption, their superheated water columns locked between Earth's depths and the sky. Earthquakes would halt mid-tremor, preserving seismic waves as static distortions in the Earth's crust. The water cycle, Earth's most fundamental clock, would cease entirely. Evaporation from oceans and lakes would stop, leaving water molecules frozen in the process of transitioning from liquid to gas. Rain would be suspended in permanent patterns across the sky, each droplet locked in its descent toward Earth. Rivers would become static sculptures, with some water flowing over waterfalls while other portions remained trapped in their channels. Weather systems would create magnificent frozen displays. Hurricane spiral arms would be locked in place, their characteristic eyewall structures preserved as atmospheric monuments. Tornado funnels would be frozen in their characteristic shapes, connecting Earth to sky in permanent sculptures of rotating air. Lightning bolts would be trapped mid-strike, their plasma channels creating branching patterns of frozen electricity stretching between clouds and ground. The biological clocks that govern life would all stop simultaneously. Circadian rhythms that control sleep and wake cycles would be meaningless without the passage of time. Plants would be caught in whatever phase of their daily cycle they occupied, some with flowers open to catch morning sunlight, others closed for the night. The migration patterns of animals would be interrupted, with birds frozen mid-flight on journeys they could never complete. Seasonal biological cycles would be permanently interrupted. Trees in temperate regions would be locked in whatever season they happened to be experiencing. Cherry blossoms in spring would never fall, autumn leaves would never complete their color change, and winter dormancy would become eternal. The precise timing that coordinates ecosystem interactions would be shattered. Even the most fundamental biological clocks would cease. The cell cycle that governs how organisms grow and reproduce would halt at whatever stage cells happen to be in. Some cells would be frozen in mitosis, their chromosomes aligned but unable to separate. Others would be trapped in DNA synthesis, their genetic material half-replicated. The universe's most reliable timekeeper, the speed of light, would become meaningless. Since speed is distance divided by time, the complete absence of time would make the concept of light speed undefined. The photons that have been racing across the cosmos for billions of years would be frozen in place, carrying information about distant events that could never be received or decoded. One of the most profound consequences of stopping time would be the complete breakdown of causality, the relationship between cause and effect. Every cause precedes its effect in time. Without time, this relationship becomes meaningless. The arrow of time is what makes the future different from the past. It's why we remember yesterday but not tomorrow, why broken glasses don't spontaneously reassemble, why entropy always increases. Stop time, and this arrow disappears entirely. In a frozen universe, there would be no before and no after, just an eternal, unchanging now. Events wouldn't happen because the very concept of events requires time. Nothing could cause anything else because causation requires a sequence of moments. This creates paradoxes for any hypothetical observer. How could they remember the moment time stopped if memory formation requires time? How could they think about the situation if thinking requires time? The observer would be caught in a logical impossibility. Even information would be frozen. Information requires change to exist. You can't convey information without altering something over time. In a time-stopped universe, all information would be locked in place, unable to flow or change. The fundamental principle of causality states that effects cannot precede their causes. This principle is built into the structure of space-time itself through the light cone concept in relativity. Every event has a light cone that defines which other events it can influence or be influenced by. These relationships depend entirely on the temporal ordering of events. Without time, the entire causal structure of the universe would collapse. Every correlation between events would become simultaneously true, creating a universe where all possible relationships exist at once, but none can be actualized through causal processes. The second law of thermodynamics, which requires entropy to increase over time, would become meaningless. Heat would neither flow from hot to cold objects nor equalize temperatures. Energy would be trapped in whatever distribution it had when time stopped. Consider what happens to logical reasoning in a timeless universe. Logic depends on sequential steps, premises leading to conclusions through intermediate stages of inference. Mathematical proofs unfold through ordered sequences of logical steps. Scientific experiments require temporal sequences of preparation, measurement, and analysis. All of these processes would become impossible without time. The concept of if-then statements, fundamental to all logic and computation, requires temporal sequence. If A, then B implies that A happens first, followed by B as a consequence. In a time-stopped universe, this logical structure collapses. There can be no conditional statements, no logical implications, no reasoning from premises to conclusions. The very foundation of rational thought would crumble. The concept of probability would also break down. Probability distributions describe the likelihood of events occurring over time. Random processes like radioactive decay or quantum measurements require time to generate their probabilistic outcomes. In a frozen universe, all probability distributions would be meaningless because no events could occur to realize the predicted outcomes. Think about flipping a coin. The probability of heads or tails exists only because the coin can land and the outcome can be observed over time. In a time-stopped universe, a coin frozen mid-flip would exist in a state where probability has no meaning. It's neither heads nor tails, not because it's in quantum superposition, but because the concept of landing requires time to complete. Even more fundamentally, the notion of existence itself becomes problematic without causality. How can something be said to exist if it cannot affect or be influenced by anything else? Existence seems to require the ability to participate in causal relationships, to influence and be influenced by other entities. In a time-stopped universe, this ability disappears, potentially negating existence in any meaningful sense. The causal chains that connect every event in the universe would be severed simultaneously. A photon from a distant star that has traveled for millions of years would be frozen inches from an astronomer's telescope, unable to complete the causal chain that would inform us about stellar evolution. The light carries information about nuclear fusion processes that occurred in the star's core, but this causal connection between stellar physics and human knowledge would be permanently broken. The arrow of time is intimately connected to the concept of entropy. In normal circumstances, entropy always increases, creating an irreversible flow from order to disorder. This is why you can easily break an egg but cannot easily unbreak it. Why perfume spreads throughout a room but never spontaneously reconcentrates. The statistical nature of entropy increase creates the psychological arrow of time that defines our experience of past and future. In a time-stopped universe, entropy would be frozen at its current value. No further increase would be possible, but more importantly, the statistical processes that drive entropy increase would be completely halted. Molecules would be unable to move from ordered to disordered states. Heat would be unable to flow from hot to cold regions. The fundamental asymmetry that distinguishes past from future would vanish. Memory itself is a causal process that creates connections between past experiences and present consciousness. Each memory formation requires a sequence of neural events. Sensory input triggers electrical activity, which causes biochemical changes, which strengthen synaptic connections, which enable future recall. Break this causal chain by stopping time, and memory formation becomes impossible. But the problem goes deeper than just stopping new memory formation. Existing memories depend on ongoing causal processes to maintain their integrity. The proteins that maintain synaptic strength are constantly being synthesized and degraded. The electrical patterns that represent stored information require continuous metabolic support. Without time, these maintenance processes would halt, potentially causing all existing memories to decay into meaningless static patterns. The very concept of identity relies on causal continuity. You are you because of the unbroken chain of cause and effect that connects your past experiences to your present consciousness. Your personality, your knowledge, your relationships, all of these emerge from causal processes that unfold over time. In a time-stopped universe, identity would fragment into disconnected moments with no continuity or relationship between them. Language and communication depend fundamentally on temporal causality. When you speak, your words cause sound waves that travel through air and cause vibrations in a listener's eardrum, which cause neural activity that causes understanding. Every step in this chain requires time and causal sequence. Remove time, and communication becomes impossible not just practically, but conceptually. Even the meaning of words depends on temporal context. The word before refers to earlier points in time, after to later points. cause, and effect are inherently temporal concepts. In a truly timeless universe, most of human language would become meaningless because it evolved to describe relationships and processes that require time to exist. The laws of physics themselves are fundamentally causal. Newton's laws describe how forces cause changes in motion over time. Maxwell's equations show how changing electric fields cause magnetic fields and vice versa. Einstein's relativity reveals how mass and energy cause curvature in spacetime. Quantum mechanics describes probabilistic causal relationships between measurements and outcomes. Remove time, and these causal relationships become undefined. Forces cannot cause acceleration because acceleration is change in velocity over time. Changing fields cannot cause other changing fields because change requires time. Mass cannot cause space-time curvature because the mathematical description of curvature involves temporal derivatives. The bootstrap paradox would become absolute in a time-stopped universe. This paradox asks, what would cause time to restart if time is needed for causation to occur? It's like asking what could light a match in a universe where fire doesn't exist. Any mechanism that could restart time would itself require time to operate, creating an impossible logical loop. Perhaps most disturbing is the realization that causality isn't just a convenient way to describe how things happen. It appears to be fundamental to the very concept of happening itself. Without causal relationships, events cannot occur. Without temporal sequence, states cannot change. Without the arrow of time, the universe becomes not just static, but meaningless. In our everyday experience, causality is so fundamental that we rarely question it. We assume that actions have consequences, that decisions lead to outcomes, that the present moment emerges from the past and gives birth to the future. A time-stopped universe would reveal causality as perhaps the most precious and fundamental feature of reality, the invisible foundation that makes everything else possible. Temperature as we know it would become meaningless in a time-stopped universe. Temperature is actually a measure of how fast molecules are moving on average. Fast-moving molecules mean high temperature. Slow-moving molecules mean low temperature. If time stopped, molecular motion would cease entirely. Every molecule would be locked in its current position and velocity. By the standard definition, this would mean everything instantly reaches absolute zero, negative 273.15 degrees Celsius. But even this description isn't quite right. Absolute zero is defined as the temperature at which molecular motion stops. In a time-stopped universe, molecules don't gradually slow down to zero motion. They simply freeze instantly wherever they happen to be. Heat transfer would become impossible. Heat normally flows from hot objects to cold objects through molecular collisions and electromagnetic radiation. Both processes require time to occur. Frozen molecules can't collide, and electromagnetic radiation can't propagate. This means a time-stopped universe would be thermodynamically impossible. The laws of thermodynamics describe how energy flows and transforms over time. Without time, these laws become meaningless, and the concept of energy itself becomes questionable. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed from one form to another. This transformation requires time to occur. In a frozen universe, energy would be trapped in its current forms forever. The second law of thermodynamics requires entropy to increase over time, leading to thermal equilibrium as temperature differences even out. This process would halt instantly in a time-stopped universe. Hot objects would remain hot, cold objects would remain cold, and no thermal equilibration could occur. The universe would be divided into permanent thermal zones with no possibility of energy exchange between them. Consider what happens to phase transitions, the processes by which matter changes between solid, liquid, and gas phases. Ice melting into water requires time for molecular bonds to break and reform. Water boiling into steam requires time for molecules to gain enough kinetic energy to escape the liquid phase. All of these transitions would halt mid-process, potentially creating strange hybrid states where matter is caught between phases. A pot of water on a stove would be frozen in whatever state of heating it was in. Some regions might be liquid water, others might be steam bubbles forming but unable to rise, and still others might be water molecules in the process of breaking free from liquid bonds, but unable to complete their escape into the gas phase. The result would be a substance that is neither fully liquid nor fully gas, but trapped in an impossible intermediate state. Crystallization processes would freeze mid-formation. Salt crystals growing in evaporating seawater would stop expanding. Snowflakes forming in clouds would be trapped in partial completion, creating a museum of frozen crystal growth. Each snowflake would preserve the exact moment of its formation, with some ice crystals fully formed while others remain incomplete, creating impossibly complex geometric patterns that could never be completed. Metal alloys cooling from molten states would preserve their exact atomic arrangements at the moment of freezing, potentially creating new forms of matter that could never exist under normal circumstances. The careful control of cooling rates that metallurgists use to create specific material properties would become irrelevant, as every alloy would be locked in whatever microstructure it had when time stopped. The kinetic theory of gases would break down completely. This theory explains gas pressure as the result of countless molecular collisions with container walls. Without time, these collisions cannot occur, making the concept of gas pressure meaningless. Gases would neither expand to fill their containers nor respond to changes in volume or pressure. The ideal gas law, which relates pressure, volume, and temperature, would become undefined. A balloon filled with helium would be frozen in its current shape, but not because the gas inside is maintaining pressure against the balloon walls. Instead, the helium atoms would be locked in position, unable to move or collide with anything. The balloon would maintain its shape purely because nothing could change, not because of any physical forces or pressure relationships. Chemical equilibrium would be permanently frozen. Many chemical reactions exist in dynamic equilibrium, where forward and reverse reactions occur at equal rates. This balance requires time to maintain. In a frozen universe, reactions would stop mid-process, preserving the exact molecular ratios that existed at that moment. Catalysts would be trapped with their substrate molecules, unable to complete their facilitation of chemical reactions. An enzyme might be caught in the middle of its catalytic cycle, with the substrate molecule bound in the active site, but unable to be transformed into products. The precise molecular dance that allows enzymes to lower activation energy barriers would be interrupted, leaving biological catalysts as static sculptures of interrupted chemistry. Thermal expansion and contraction would cease entirely. Materials expand when heated and contract when cooled due to increased or decreased molecular motion. Without time, no thermal expansion could occur, freezing materials at their exact dimensions when time stopped. This would affect everything from the length of bridges, to the operation of thermostats, to the behavior of gases in containers. The thermal expansion joints in bridges and buildings would be locked at whatever size they happen to be. These joints are designed to accommodate the expansion and contraction of materials with temperature changes, but in a time-stopped universe, they would become permanent fixtures with no ability to accommodate any changes because change itself would be impossible. Heat engines would become impossible. These devices work by allowing heat to flow from a hot reservoir to a cold reservoir, extracting work in the process. Without time, heat cannot flow, and no work can be extracted. Steam engines, internal combustion engines, even the thermoelectric generators that power some spacecraft would all become non-functional sculptures of frozen thermodynamics. The steam in a steam engine would be trapped mid-expansion. The pistons would be locked in whatever position they occupied when time stopped. The thermodynamic cycle that converts heat into mechanical work would be interrupted, with some stages of the cycle frozen in progress while others remain incomplete. Convection currents would cease instantly. These currents, driven by temperature differences that cause density variations in fluids, would stop mid-flow. Weather patterns driven by convection would be frozen in place. Ocean currents caused by temperature differences would halt. Even the convection in a pot of boiling water would stop, creating static patterns of heated and cooler regions. The Earth's mantle convection, which drives plate tectonics and continental drift, would freeze instantly. The slow churning of rock that has been reshaping our planet's surface for billions of years would stop, preserving the current positions of continents forever. Volcanic activity driven by convective flow would cease, freezing magma chambers in their current states. Brownian motion, the random movement of particles suspended in fluids, would disappear completely. This motion, caused by molecular collisions, would be impossible without time for collisions to occur. Dust particles suspended in air would be locked in position, creating three-dimensional sculptures of frozen particle distributions. The statistical mechanics that underlies our understanding of temperature would collapse. Temperature is fundamentally a statistical concept. It represents the average kinetic energy of a large number of particles. In a time-stopped universe, this statistical description would become meaningless because the molecular motion that creates temperature variations would be completely absent. Phase diagrams that show the relationships between temperature, pressure, and phases of matter would become historical artifacts. These diagrams map the conditions under which substances exist, as solids, liquids, or gases, but all of these relationships depend on molecular motion and energy transfer over time. Without time, phase diagrams would be replaced by static maps of whatever phase each region of matter happened to be in when temporal flow ceased. Superconductivity and superfluidity, quantum phenomena that occur at extremely low temperatures, would be frozen in whatever state they occupied. Cooper pairs in superconductors would be locked in their quantum correlated states. Superfluid helium would be trapped in its frictionless flow state, but unable to actually flow because flow requires movement over time. Perhaps most fundamentally, the concept of thermal energy would lose all meaning. Thermal energy is kinetic energy at the molecular level, the energy of random molecular motion. Without motion, there can be no kinetic energy. Without kinetic energy, the concept of thermal energy becomes undefined. Heat, one of the most basic forms of energy in the universe, would simply cease to exist as a meaningful concept. In a world where time has stopped, all forms of communication would instantly become impossible. Sound waves are pressure variations in air that travel at about 343 meters per second. If time stopped, these waves would freeze mid-transmission. A person speaking would have their voice trapped in expanding bubbles of compressed air around their mouth. The sound waves would be locked in place like invisible sculptures stretching between speaker and listener. Radio waves, Wi-Fi signals, and cell phone communications all depend on electromagnetic radiation traveling at the speed of light. These signals would freeze instantly, trapping digital information in motionless electromagnetic fields. Even light-based communication would fail. The photons carrying visual information would be locked in place between their source and destination. Written words would become unreadable, because the light reflecting off them couldn't reach your eyes. Perhaps most strangely, even direct physical contact wouldn't allow communication. When you touch something, you're feeling electromagnetic forces between atoms. These forces propagate at the speed of light, so even the sensation of touch would be frozen mid-transmission. The complex dance of electromagnetic interactions that allows atoms to resist compression and create the sensation of solid matter would be trapped in whatever state it was in when time stopped. Consider what happens to a simple conversation. When you speak, your vocal cords vibrate, creating pressure waves in the air. These waves travel outward in all directions at the speed of sound. In a time-stopped universe, a speaker's words would be trapped as concentric spheres of compressed and rarefied air expanding outward from their mouth, but unable to propagate any further. The complexity of these frozen sound patterns would be extraordinary. Each word would create its own unique pressure pattern. Vowel sounds would appear as relatively smooth wave formations, while consonants would create more complex, jagged patterns. The emotional tone of the speaker, anger, joy, sadness, would be preserved in the subtle frequency modulations trapped within the static sound waves. A singer's voice would create even more intricate patterns. The harmonics that give different voices their unique timbre would be frozen as complex interference patterns in the air. A choir would produce overlapping spheres of harmonic content, each voice contributing its own frozen contribution to what would have been a unified musical experience. Digital communication faces even more severe challenges. Cell phone signals encode information as electromagnetic waves with specific frequency and amplitude modulations. In a time-stopped universe, these modulated signals would be trapped as static electromagnetic field patterns extending between cell towers and phones. The binary code representing text messages, phone calls, and data would be preserved as frozen patterns of electromagnetic energy, but completely unable to be transmitted or received. The internet relies on a vast network of electromagnetic signals traveling through fiber optic cables, copper wires, and wireless connections. Every email, every web page request, every video stream would be frozen mid-transmission. Fiber optic cables would contain trapped pulses of infrared light carrying digital information. Ethernet cables would have electrical signals locked in their copper conductors. Wi-Fi routers would be surrounded by frozen electromagnetic fields containing packet data. Imagine the visual complexity if we could somehow see all these trapped signals. The air around us would be filled with overlapping electromagnetic patterns from countless communication devices. Cell phone signals would create geometric patterns connecting phones to towers. Wi-Fi signals would form complex, three-dimensional networks around routers and devices. Bluetooth connections would appear as short-range electromagnetic sculptures linking nearby devices. Satellite communication would create fascinating patterns extending into space. GPS signals from satellites would be frozen as precise timing patterns that could never reach their destinations. Television broadcasts would be trapped as modulated electromagnetic waves extending from transmission towers. International communications bounced off satellites would be locked in their paths between Earth and space-based relay systems. Even the most basic form of visual communication, reading, would become impossible. Reading requires light to reflect off written text and travel to your eyes, where it triggers photochemical reactions in your retina. In a time-stopped universe, the photons reflecting off this page would be frozen in space, unable to complete their journey to create vision. The text would exist, but no one could see it. Sign language would face similar problems. This visual form of communication depends on reflected light, carrying information about hand movements and facial expressions from signer to observer. Without time for light to propagate, sign language would be as impossible as any other form of communication. The neurological basis of communication would also be disrupted. When you hear spoken words, sound waves cause your eardrum to vibrate, which moves tiny bones in your middle ear, which creates pressure waves in the fluid of your inner ear, which bends hair cells that generate electrical signals sent to your brain. Every step in this process requires time. In a time-stopped universe, this entire chain of neural processing would be frozen at whatever stage it was in when time stopped. Similarly, speech production requires complex timing. Your brain sends electrical signals to muscles in your larynx, tongue, lips, and respiratory system. These muscles must contract and relax in precisely timed sequences to produce intelligible speech. The acoustic properties of your vocal tract must change over time to create different sounds. Without time, speech production would be impossible, even if someone could somehow hear the results. Written communication would preserve information but render it inaccessible. Books, newspapers, computer screens, and handwritten notes would all contain their textual information, but the light carrying this information from page to eye would be frozen in transit. Libraries would become museums of trapped information, their contents visible but unreadable. Electronic displays would create particularly interesting frozen patterns. LCD screens work by controlling the polarization of light, passing through liquid crystal cells. LED displays create light through electroluminescence. OLED screens use organic compounds that emit light when electricity flows through them. All of these processes would be frozen mid-operation, with some pixels caught in the process of changing state while others remain static. The electromagnetic spectrum would become a three-dimensional artwork of trapped communication. Radio waves carrying AM and FM broadcasts would be frozen as modulated electromagnetic patterns extending from transmission towers. Television signals would create complex field patterns encoding video and audio information. Microwave communication links would appear as focused beams of trapped electromagnetic energy. Even nonverbal communication would fail. Facial expressions convey information through subtle changes in muscle tension and positioning that occur over time. A smile is not a static configuration, but a dynamic process of muscle contraction and relaxation. Body language depends on posture changes and movements that unfold temporally. In a time-stopped universe, all nonverbal communication would be frozen in random intermediate states that convey no meaningful information. The chemical basis of communication would also halt. Pheromones, chemical signals that many animals use to communicate, require time to diffuse through air or water and bind to receptors in other organisms. In a time-stopped universe, these chemical messengers would be trapped in their current locations, unable to complete their journey from sender to receiver. Digital storage devices would preserve information but make it inaccessible. Hard drives rely on spinning disks and moving read-write heads. Solid-state drives depend on electrical signals flowing through transistors. Both types of storage would be frozen in whatever state they were in, with some data potentially caught mid-write, creating corrupted files that could never be completed or recovered. The concept of information itself would become problematic. Information theory defines information as the reduction of uncertainty, but this reduction requires a temporal process of observation and interpretation. In a time-stopped universe, information would exist as static patterns in matter and energy, but without the ability to be processed, transmitted, or interpreted, it would lose its fundamental character as information. Perhaps most tragically, the human connections that communication enables would be severed completely. The words of love between partners, the laughter shared between friends, the knowledge passed from teacher to student, all would be trapped as frozen patterns of energy and matter, preserving the form of communication, but destroying its essence. This brings us to the ultimate question. Once time stopped, could it ever start again? This might be the most disturbing aspect of our thought experiment. For time to restart, something would have to cause the restart, but causation itself requires time. You'd need some mechanism operating outside of time to kickstart temporal flow again. But physics suggests nothing can exist outside of space-time. Even the quantum vacuum requires time to function, with virtual particles constantly appearing and disappearing. Some theories in physics suggest time might not be fundamental, but might emerge from more basic properties of reality. If these theories are correct, perhaps time could restart if these underlying properties somehow resumed their function. But more likely, if time could somehow stop, without destroying the universe entirely, it would remain stopped forever. The frozen universe would exist in an eternal moment, with no possibility of change, no hope of restart, no escape from the ultimate stasis. This reveals something profound about the nature of time itself. Time isn't just a dimension we move through, it's the very foundation that makes existence possible. Without time, there's no causation, no change, no consciousness, no meaning. Time isn't just part of reality, it is reality. The question of restarting time highlights the bootstrap paradox. How can time begin without time already existing to enable the beginning? It's like asking, what could light a candle in a universe where fire doesn't exist? Consider the various theoretical mechanisms that might restart time. In some speculative physics theories, time emerges from the quantum foam at the Planck scale, where space-time itself becomes granular and uncertain. If time stopped, perhaps quantum fluctuations at this fundamental level could spontaneously recreate temporal flow. But this mechanism faces the same paradox. Quantum fluctuations require time to occur. The uncertainty principle itself is time-dependent, describing how quantum systems evolve probabilistically over time. Another possibility involves the many worlds interpretation of quantum mechanics. Perhaps in stopping time in our universe, we've created a branch point where other universes continue with normal temporal flow. Maybe these parallel timelines could somehow influence our frozen reality and restart time. But this explanation requires inter-universal causation, which is purely speculative and would need to operate through mechanisms that transcend space-time entirely. The mathematical structure of such interdimensional causation would be extraordinary. You'd need causal relationships that operate across different temporal dimensions, with one universe's time serving as the causal agent for another universe's temporal restart. But causation itself is defined within space-time, so the concept of transdimensional causation may be logically incoherent. Some theories in cosmology suggest that time might be cyclical rather than linear. In these models, the universe undergoes eternal cycles of expansion and contraction, with time potentially stopping and restarting at each transition. But even these cyclical models require some form of metatime, a higher-order temporal dimension, within which the cycles occur. We'd simply be pushing the problem up one level without solving the fundamental paradox. The ekpyrotic universe model, which proposes that our universe began from the collision of higher dimensional brains, might offer another avenue for temporal restart. Perhaps our frozen universe could be restarted by collision with another brain in higher dimensional space. But this scenario requires the existence of metatime in which brain collisions can occur, and it assumes that higher dimensional physics operates according to rules that allow for the restart of lower dimensional temporal flow. String theory, which suggests that our universe might be a hologram projected from a higher dimensional boundary, could potentially allow for temporal restart through changes in the boundary conditions. But again, this requires that the higher dimensional space has its own temporal structure, and it's unclear how changes in higher dimensions could restart time in a dimension where time has completely stopped. The most unsettling possibility is that time, once stopped, would remain stopped forever. The frozen universe would exist as an eternal monument to a moment that can never change or end. Every pattern of matter and energy would be preserved exactly as it was, creating a perfect museum of reality that no one could ever visit. This eternal stasis wouldn't be experienced as an eternity of waiting, because experience itself requires time. It would simply be a timeless state where the concept of duration has no meaning. This permanence would be absolute in ways that challenge our deepest intuitions about reality. In our normal experience, even the most permanent things eventually change or decay. Mountains erode, stars burn out, protons may eventually decay. But in a time-stopped universe, change would be not just impossible, but inconceivable. The state of the universe would be as permanent as mathematical truth, not because it's stable or well-preserved, but because the very concept of change would have no application. Yet perhaps the very impossibility of stopping time reveals something important about the nature of reality. The fact that our thought experiment leads to logical contradictions and physical impossibilities suggests that time is not optional for existence. Time might be so fundamental to reality that its absence would negate the very possibility of existence itself. In this view, the question, "What if time stopped?" is like asking, "What if existence stopped existing?" A meaningless question because the premise negates itself. The anthropic principle might offer another perspective. This principle suggests that we observe a universe compatible with our existence because we couldn't observe any other kind. Perhaps time cannot stop in any universe that contains observers to ask the question. The very fact that we can contemplate stopping time might be evidence that time cannot be stopped, because our existence as thinking beings requires the continuous flow of temporal experience. But this leads to an even deeper question. Could there be universes where time never started in the first place? Mathematical structures exist timelessly. The Pythagorean theorem doesn't come into being or go out of existence. It simply is, eternally and unchangingly. Perhaps there are mathematical universes that exist in this timeless way, containing no processes, no change, no experience, no observers to wonder about their own nature. The emergence of time from timelessness presents perhaps the deepest mystery in physics. How did temporal flow begin in the first place? The Big Bang Theory describes the universe's evolution from its earliest moments, but it doesn't explain how time itself came to be. Some theories suggest that time emerged spontaneously from a quantum vacuum, but this pushes the mystery back one level. What made the quantum vacuum temporal rather than timeless? Loop quantum gravity proposes that time itself might be quantized, composed of discrete moments like frames in a movie. If time has this granular structure, perhaps it could restart one quantum moment at a time. But even this model requires some meta-temporal process to advance from one quantum moment to the next, recreating the original paradox at a more fundamental level. The holographic principle suggests that all the information in our three-dimensional universe might be encoded on a two-dimensional surface. Perhaps time restart could be accomplished by changes in this holographic encoding. but the holographic surface itself would need to exist in a space with temporal structure to allow for the changes that would restart our universe's time. Perhaps the most profound insight from our exploration is that time restart might not just be physically impossible, but logically meaningless. The concept of restart implies a temporal process, a before state without time followed by an after state with time. But this transition would itself require time to occur, creating a logical contradiction that may be unsolvable even in principle. This brings us full circle to the profound mystery of time itself. Despite centuries of scientific investigation, we still don't fully understand what time is or why it flows in only one direction. We can measure it with incredible precision, use it in our equations to predict the behavior of everything from subatomic particles to galactic clusters, and base our entire technological civilization on its regularity. But the fundamental nature of time remains one of the deepest mysteries in physics and philosophy. The next time you check your watch or feel impatient for something to happen, remember, the flow of time isn't a convenience or an obstacle. It's the miracle that makes everything else possible. Every heartbeat, every thought, every moment of consciousness depends on time's steady flow. Without time, there would be no stories to tell, no experiences to remember, no future to anticipate. Time isn't just the stage on which reality performs, it's the performance itself. In imagining a world where time stops, we've discovered something remarkable. Time isn't just fundamental to physics, it's fundamental to existence itself. The universe without time isn't just different from our universe. It's not a universe at all. It's a static sculpture of matter and energy. Beautiful, perhaps, but empty of all the processes that make reality real. The flow of time, which we often take for granted, turns out to be the most precious gift of existence, the gift that makes all other gifts possible.